Welcome to the seventh session of the Unit 6 acceptance sampling of the subject that is called as statistical quality control. So on completion, the course outcome is on the completion of that. The students will be able to understand the basic concepts of the acceptance samplings. In the last sessions, we have discussed about the problems on the OC curves, and the problems we have discussed, that is based constructions of the curve, OC curve, based on the calculation and based on the by using the table. So now let us take once again we will solve some of the problems on the OC curve. A single sampling plan has n is equals to 110, c is equals to 3, c is equals to 3. So it means that the sample size is 110 and the c acceptance number is 3. So it means that we need to find out the probability of the acceptance for getting the 0 defectives, probability of getting the acceptance for 1 defective, like 2 defectives and 3 defectives. So the lot size as large as compared with the sample size. So plot OC curve and values of LTPD for which the probability of the acceptance are 0.95, 0.9, 0.95, 0.51, and 0.1 respectively. So now here he has given the value PA. PA is equals to 0.95 and NP is equals to 1.3. So NP is equals to 1.3. For this, the value of PA is equals to 0.95, NP is equals to 0. NP is equals to 1.3 from the tables we will get. So P is equals to NP is 1.3. So P will be equals to 1.3 divided by the samples 110, that is equals to 0.012, or it is equals to 0.12%. For PA is equals to 0.5. So the second value, first value we have taken, this one 0.95. So the second value is 0.51. For the value of PA is equals to 0.51, NP will be 3.5. For C is equals to 3. For C is equals to 3, we'll get NP is equals to 3.5 from the table. So then P will be equals to 0.0. You have to divide this NP value 3.6 by 110 by the sample size. When you divide, you will get 0.0327, or you can say that 3.27%. Now, the next value is 0.1. PA is 0.1. You can see here, PA is 0.1. For the 0.1, for the value we will get for PA 0.1. For PA 0.1, NP is equals to, we will get 6.6 from the table for the value of C. C is equals to 3, PA is equals to this much, we'll get NP is equals to 6.6. Then P will be equals to the 0.06, which is nothing but the 6%, I can say. So now you can plot the curve for that. So NP is equals to C here 1.1. You can take here, you can see the problem. So first value, NP value is 1.3, second value is 3.6, third value is 6.6, 1.3, 3.6, 6.6. Now these are the values here he has given, and now we will take some of the values above 1.3 and till we can go to the 6. PA is equals to 6%. You can see here 0.01. So this is a value he has given, 0.03 and 0.04. So these values we already he has given here. So see here 0.012, PA is equal to 0.12, 0.03, and 0.06. So these are the three values he has given. And apart from that, we have taken some of the different values for NP. So now see here 0 for 0.01, NP will be equals to 1.1 from the table you will get, and for the value of C is equals to 3, for P is equals to 0.01, NP is equals to 1.1 to 1.1, for the value of C is equals to 3. So we'll get PA is equals to 0.0974. So like that, we'll get all these values 0.95, 0.1819, 0.581, 0.5, 0.0, 0.359, 0.202, 0.105. So when you plot PA versus P, PA versus P, you will get a curve. That curve is called as the OC curve. So we'll take another problem here. So draw the OC curve for the sampling plan. N is equals to 10,000, small n is equals to 150, and C is equals to 2. So determine OC. We need to draw the OC curve here. If AQL, acceptable quality level, is 1%, LTPD is 4%. So determine also AQL and LTPD if alpha is equals to 0.05, beta is equals to 0.1. So what the AQL values for the sampling plan? So this is a problem we need to solve it here. So now from this table, say here, now in the problem he has given AQL is 1%. You can see here AQL is 1% and LTPD is 4%. You can see the LTPD, it is 4%, 0.04. So now what we have done is AQL, you see the tabular column AQL. So in the third row, 1, 2, 3, third row here AQL is 1% and the LTPD is 0.04. That is a 4%, I can say. So this is a 4% LTPD and AQL is what? It is 1%. So now I need to take some of the values above the AQL and some of the values below the LTPD. So AQL is 0.01. So I will go below that, that is 0.05 and then 0. For 0, PA will be equals to always equals to 1 and PA it will be equals to 1 and then for 0.05 NP is equals to, we'll get 0.75. So for that PA will be equals to 0.95959 and for AQL 0.01, for that we'll get NP is equals to 1.5 and it is equals to 0. PA will be equals to 0.809. Similarly, then we have to go down, that is AQL is 0.01. You can go for next value 0.02, 0.03, 0.04 and 0.05. So for that value, we will get for the NP, we'll get NP and the value of this thing for the value of C, we will get the value of the PA as shown in the tabular column. And for that PA, when you multiply that PA with P, so you will get AQ or AOQ, that is the accepted quality level, outgoing quality, that is the product of the two things, that is the P into PA. So you form another table, another column where it indicates P into PA, and the P into PA will give you the acceptance quality, outgoing quality, acceptance of the outgoing quality. So now here is a slight some calculation is here. We can see this calculation. So 1 minus alpha is AQL at 1%. That is okay for the 1%. 1% AQL. If for the AQL 1% is 0.809. So it is 1 minus alpha is AQL and beta is equals to 0.06. You can see LTPD. So you can see here 0.062. So for LTPD, it is 1.1%. So 1 point, or I can say that it is the for the 4%. So AQL for 0.02, alpha is 0.05, LTPD for that is 1, and AQL is 0.0085. That is the maximum of AQL. So these are the things that you know already I have discussed. And now we'll go to the next slide here. So now, so still now we have discussed something about the single sampling plan. And in the single sampling plan, we have discussed the how to get the acceptance number. Okay, with the help of the three formula, hypergeometric formula, Poisson's formula, and the binomial distribution formula. Then we have studied in the single sampling plan the construction of the OC curve, and the construction of the OC curve. As you know that we can construct the OC curve by the two methods. One is by taking the value directly from the G table, from the statistical tables, and then we can plot the curve. We will get the OC curve. And the second one is we can construct the OC curve by means of the calculations, that is the by means of a formula, that is sum of x tends from 0 to n, n cx into p to the power of x into 1 minus p, 1 minus p to the power of n minus x, where you need to change the value, where you need to put the value 0, the value of the p, which starts from 0.01 to 0.02, 0.03, 0.04, like that, till you can go till it cross LTPD. You need to take, and below the AOQ also you need to take some values, and then you need to construct the curve that is called as the OC curve. So like that we have studied the single sampling plan. Now we have to study about the double sampling plan. So what exactly the double sampling plan? The name itself indicates that a double sampling plan is a plan where we are going to take the two samples from the lot. So a double sampling plan involves the probability of putting the decision regarding the acceptance or rejections of the lot until a second sample has been drawn. So this plan provides for making a second sample when the result of the first sample are marginal, which is often the case when the lots are of the borderline quality. So double sampling plan has the four variables. It has got the four variables. So once again, so this is known as the double sampling plan. So once again, I'll tell you a double sampling plan. It involves the possibility of putting the decision of regarding the acceptance or rejections of the lot until the second sample has been drawn. So provides for this plan provides for making the a second sample when the results of the first sample are marginal, which is often the case when the lots are of border quality line. So then only we have to go for the second sample here. The second DSP, that is a double sampling plan, has the four variables. So we'll know that what are the four variables. Like in the single sampling plan, there is a sample size n and the acceptance number. But here, as there are two sampling plans will be there, two samples will be there. So naturally, the first sample will be having n1. That is, the n1 is called as the first sample size, and c1 is called as the acceptance number for the first sample. Maximum number of the defectives which will permit the acceptance of the lot. So C1 is the maximum permissible limit that will accept with which we can accept the lot. N2, so N2 stands for the second sample size, and C2 is the acceptance number for C2 is the acceptance number for the sample 2. For n plus 1, for n plus n2, the maximum number of defectives that will permit the acceptance of the lot on the basis of the two samples. So that is called as the double sampling plan. So now we'll take an example here. So this example shows that The lot size is 1000. Small n is 30, and small n1 is 30, n2 is 50, and c2 is 3. So so what does it mean? So this plan is as follows. The lot contains 1000 pieces. So the lot contains 1000 pieces. Capital N is equal to 1000. First sample of that is first sample size is 30. So that's what the first sample of 30 pieces is subjected to inspection. So it means that we need to select randomly. We need to select 30 pieces from the lot of 1000 items. That is the first, I can say that sample, first for the inspections. So now, so the value of C1 is 1. It is actually, it has not been given there. So the value of N1, N2, C1 is 1. Okay. So assume that the C1 is 1 here. So here it is explaining that if the sample contains either 0 or 1 defective, the lot is accepted. It means that the value of the C1 is 1 here. So value of you take out 30 pieces, randomly you pick the 30 pieces from the lot of 1000 items, and and as the C1 is given as 1, so then it means that if the sample contains either 0 or 1 defectives, the lot will be accepted. So, so the lot will be accepted. So next, it says that N2 is 50 and C2 is 3. That is, if the sample contains more than 3 defectives, the lot will be rejected. So then if the sample contains less than or 3 equals 3 defectives, then the second sample of 50 pieces will be taken. So it means that, so here, first we need to select, randomly we need to select 30 articles from the lot of 1000 items. Then here it is C1 is equals to 1. If, if, if there are 0 defective or 1 defective, then the accept the lot. Otherwise, you have to reject the lot. So then the number of the defective, once again, if the number of the defective exceeds the 3, if the first sample, if the number of the defective is more than 3, then you need to reject the lot. And if the sample contains less than or equal to 3, so then you have to go for the sample 2. You have to draw 50 pieces from the lot. That is the second sample. So both the samples are mixed now. So that is the sample number 1 and the sample number 2. And thus 80 pieces are subjected for the inspection. So how we got the 80 pieces? Because the first sample is having 30 pieces and the second sample is having 50 pieces. And then, so these 30, sample 1 and sample 2, they are mixed together. And when you mix that one, you will get 80 pieces, and they are subjected for the inspections. The lot is accepted if both the samples together yields 3 or less defective. So when you add all both the samples, when it becomes 80, so then when you inspect it, when you inspect this 80 items, and out of the 80 items, because C2 is 3, so if the lot will be accepted, both the samples together yields 3 or less defective. So lot is rejected if both the samples contain yields more than 3 defective. That's how a single double sampling plan will work out. So now, how to implementation of double sampling plan? So here the step-by-step method has been given. How exactly we can implement? How exactly we can actuate the second double sampling plan? Suppose a lot of the same size, that say example capital N are received from the supplier, or the final assembly line submitted for the inspection, one at a time. The procedure for implementing the double sampling plan to arrive at a decision about the lot. So a double sampling plan is described in the following steps. So it has been explained in the following steps. So what are the steps involved, in implementing the double sampling plan? So the first, as we know that there are N1 and N2 and C1 and C2. We already have discussed this point. So as it is double sampling plan, so there will be N1 and C1 and N2 and C2. N1, C1 stands for the first sample and N2, C2 stands for the second sample. So now first sample is having N1. So now we'll see here, we draw a random sample, that is the first sample of size N1 from the lot received from the supplier or the final assembly. So the first step is we have to choose randomly the first sample, that is N1, from the lot supplied by the for the final assembly or the supplied by the supplier. So then the second step, what we need to do here. So we inspect each and every unit of the sample and classify it as defective or non-defective. So that is the second step. In the second step, whatever the items that has been selected randomly from the lot, so there we have to inspect each and every unit of the sample, and then we need to classify it. Then we need to classify it as defective or non-defective. At the end of the inspection, we count the number of the defective units found in the sample. Suppose the number of defective units found in the first sample is say D1. So here we are bothered about the defective samples. We are not bothered about the non-defective samples. Say the say here in the first step we have taken the random sample of the N1 items, and then we have inspected each and every unit of the sample. Then we have separated the defectives and non-defectives. Then we need to count the number of the defective that is present in the sample one. So there, the number of the defectives, we can say that it is the D1. D1 is the number of defectives in the sample one. So next, the third step, we compare the number of defective unit D1 found in the first sample with the stated acceptance number C1 and C2. So whatever the D1 we will get, we need to compare it with the C1 and C2. Here in the single sampling plan, we used to compare the D1 with the C1 itself. Now here there are two samples. We need to draw the two samples, and there are two acceptance numbers C1 and C2. That's why once you get D1, you need to compare that D1 with C1 and C2. So that is the third step. And the fourth step, we need to take the decision on the basis of the first sample as follows. Under the sampling plan, under the acceptance sampling plan. Now, how to take the decision? So now we are comparing D1 with C1 and C2. Now, how we have to take the decision? If the number of the defective D1 in the first sample is less than or equal to C1, if the number of the defectives in the first sample, which is less than C1 for the first sample, that is what it is given. D1 is less than or equal to C1. We accept the lot. We have to accept the lot. Then if the D1 is greater than C2, we need to reject the lot. We have to reject the lot. If D1 is less than or equal to C1, so we have to accept it. If D1 is greater than C2, we need to reject the lot. But if C1 is less than, if the C1 is less than D1 and which is less than C2, the first sample is failed under the rectifying sampling plan. So if D1 should be less than or equal to C1. So we accept the lot and replace the defective items found in the same sample by the non-defective items. So that is the one stage. So next one is, if D1 is greater than D1 itself is greater than C2, we accept the lot after inspecting the entire lot and replacing the defective. Here, if D1 defective, which is there in the first sample, which is more than the acceptance number 2, so then it is come to the conclusion there will be an agreement between the customer and the producer stating that the inspecting the whole entire lot and replace all the defective units and with the defective units with the non-defective unit. But if C1 is greater than, if C1 is less than D1 and less than D2, the first sample will be failed. Step 5. Step 5. If C1 is less than D1 and D1 is less than C2, okay, so defectives are more. D1 is the defective in the first sample, which is more than the acceptance number 1, but less than the acceptance number 2, then the second sample of size N2 will be drawn. So the next one is the next step, the sixth step. We inspect each and every unit of the second sample, count the numbers of the defective units found in it, and suppose the number of the defective units found in the second unit, second sample is say D2. So now we have to select the second sample and we need to inspect all the items of the second unit and the second sample, and we need to separate the defectives and non-defectives, and the defective items will be counted in the second sample, and then we'll call that one as D2. So the seventh step, we combine the number of the defectives, that is D1 and D2, found in the both the samples. Consider D1 plus D2 for making the decision about the lot on the basis of the second sampling plan. Under the acceptance sampling, if D1 plus D2 is less than C2, so we need to accept the lot because C2 is more. And if D1 plus D2 is greater than C2, so we need to reject the lot under rectifying sampling plan. So that is about uh, the double sampling plan. So the flow charts has been given here for the sampling plan. So it says that, so first we need to select the sample, select the sample, the first sample of size N1. So it means that you need to pick N1 sample from the lot. So then count the number of defectives as D1 during the time T0. So now we need to count it. After counting it, if D1 is the number of the defectives, if D1, you can see here, you have to pick D1, you have to pick N1 size of the sample, we need to inspect. Once after inspecting, we need to count the number of the defectives. Say D1 is the number of the defectives. Now, if the number of the defectives is, see here, is this D1 is the number of the defective, which is less than or greater than the acceptance number for acceptance number C1 for the C1 for the sample 1, so then accept the lot. If this D1 is greater than C2, now compare this D1, the number of the defectives, with C2, that is the acceptance number of the second sample. So if it is greater, D1 is greater than C2, then they reject the lot. The third option here, if D1 is greater than C1, less than C2. So this is the next option here. So it means that you need to compare this D1 with the three options here. So D1 is less than C1, so accept the lot. If D1 is greater than C2, reject the lot. If D1 is greater than C1, D1 is greater than C1 but less than C2, select then only you have to go for the second sample. Next, in the second sample, count the number of the defective D2. So if now we need to compare this D2. Now we are comparing, while comparing this D2, you need to take the defectives in the first lot, that is D1. Now you add D1 plus D2. We are going to mix this D1 and D2. So this D1 and D2, if it is less than or equals to C2, so then we need to accept the lot. If this D1 and D2, if they are greater than the C2, then we need to reject the lot. So that is about the acceptance sampling plan. So now the same acceptance sampling plan here, once again, I have shown by means of the flow charts. Okay, so So you need to either you can draw this flow chart or you can draw the previous flow charts for the for your whichever one easy for you. You can choose the flow charts. Here I have given the two types of the flow charts for the double sampling plan. So here I have completed the seventh session of the unit 6, that is called as the acceptance sampling uh, of the subject that is called as statistical quality control. So thank you. Thank you very much.